All right, so this is going to be a video that's basically an entire overview of what this unit is about, and that is quadratic equations. Now, basically a quadratic equation is just a special type of polynomial equation that has a degree of 2. If you remember what polynomials are, they're basically equations that have terms, and each of those terms can have an exponent. The exponents can only be positive whole numbers or 0. So it could be 0, 1, 2, 3, 4, and so on, but it cannot be negative. Now, if it's a degree of 2, that means that the highest exponent power that you can have, the highest exponent would be a 2. And that's basically what this represents right here. It's the y equals ax squared plus bx plus c. That is a standard form of a quadratic equation because that 2 up there is the highest exponent that it has. Now, it also has a term that has an exponent of 1 with that bx, and it also has a term that has an exponent of x to the 0, which is that c times x to the 0, because x to the 0 is equal to 1 as long as x is not equal to 0 itself. Now, there are other forms of quadratic equations that you can have as well. We already went over factored form in the previous unit, but factored form looks like this, where it's y equals a times x plus m quantity times x plus n quantity. Now, that is a way of looking at a factored form of a quadratic. If you expanded this all out, it would go right back to that standard form that we kind of talked about right up here. Okay, there's also vertex form, which is this yellow right here, where it's y equals a times the quantity x minus h squared plus k. Now, this h and k represent the coordinates of the vertex. Now, we're going to talk about that in a later video. Okay, one thing that you should know between all of these forms is that a cannot be equal to 0. For this to be quadratic, a cannot be equal to 0, because if you did that, it would actually alter what the equation could be depending on which form you have. So a cannot be equal to 0 for any of these. Okay, quadratics form a graph that's known as a parabola. So basically it looks like a U or an upside down U, like what we have right here in these two pictures. Now, the graphs also show certain key characteristics of quadratic equations. Right here, for example, the x-intercepts for quadratic equations, they're called roots or solutions or zeros, or you can just call them x-intercepts. Either way, quadratic equations could have up to 2 roots. They could have 1 root, or in some cases they can have 0 roots. In this case right here, this red right here and this purple down here, they both do not actually have roots because they don't intersect the x-axis. The vertex is just where it changes from increasing to decreasing or decreasing to increasing. So it's that min or max point. In this case, it would be a min. In this case over here, it represents the max. And then every single quadratic function that's graphed has an axis of symmetry. So you'd be able to essentially fold that parabola in half, and that line where you would fold represents the axis of symmetry. The domain for quadratic equations, quadratic functions, is always going to be from negative infinity to positive infinity, unless you have some domain restriction that you want to put on it. But generally speaking, they're going to be from negative infinity to positive infinity. The range, however, is not going to be negative infinity to positive infinity. If the parabola is pointed upwards, so if it's like a U, it's going to go from the minimum value of that U, so whatever that vertex value is, that y value, and that's going to be included in the range all the way up to infinity, because we're going up forever. Now, if it was pointed down, it's going to go from negative infinity, because the lowest possible value in that case would be negative infinity, all up until that maximum value, and that maximum value will be included as well. Okay, the solving techniques. We are going to be going over 4 different solving techniques in this class for quadratic equations. We have graphing, factoring, which actually was covered in the last unit, so it's going to be a review. A technique called completing the square, and a technique involving what's called the quadratic formula. Those will be gone over in a later video. Ultimately, this is all going to be brought together, and we're going to be using these methods of solving to solve real-world application problems that involve quadratic functions. Okay, so if you have any questions about anything in this overview, again, it's just a big, broad overview of what this unit's going to be about. If you have any questions about anything on this, let me know.